need to expose database search capabilities to your AI while keeping the interface clean and properly validated. You'll see how to create a FastMCP tool that searches a database with query parameters, complete with input validation to ensure the AI provides sensible values. The pattern handles everything from query strings to result limits, all while maintaining type safety and clear documentation.
At MCP, tool. Def search database. Query, SDR equals field. Description equals search query string. Limit, int equals field. 10, description equals maximum number of results. G equals 1, la equals 100. A list. Search the database with the provided query. Hash implementation.
This demonstrates the declarative tool pattern, where Python functions become AI-callable capabilities through simple decorators. The @MCP tool decorator transforms ordinary functions into typed, self-describing endpoints that LLMs can discover and invoke, while preserving the function's native Python interface. What makes this distinctive is the complete separation between your business logic and the RPC infrastructure. You write normal Python, and the framework handles exposure, validation, and transport. The pattern works by leveraging Python's type system and decorator metadata to auto-generate tool schemas. Type annotations define the input-output contracts, docstrings provide descriptions, and the decorator registers the function with the MCP server at runtime. This creates a clean boundary where your implementation stays pure Python, while the framework manages all serialization, validation, and protocol handling. The result is a system where tools are first-class citizens, discoverable by clients without manual registration code. This approach solves the dual problems of API boilerplate and AI integration complexity. For developers, it eliminates the need to write separate root handlers, request parsers, and response serializers. Your function signature becomes the API contract. For AI systems, it provides strongly typed tools with machine-readable schemas, enabling reliable invocation without natural language ambiguity. The trade-off is some initial framework coupling, but the productivity gain for tool-heavy applications typically outweighs this cost. Let's break it down line by line.
At MCP, tool. Def search database.
The @MCP tool decorator registers this function as an AI-callable tool in FastMCP. It transforms the Python function into a structured tool that AI models can discover, understand, and invoke, using the type hints and docstring to generate the tool's schema automatically. This is the standard pattern for exposing functionality to AI agents in the FastMCP framework.
Query, SDR equals field. Description equals search query string.
This defines the query parameter as a required string with a descriptive label. The field class from Pydantic adds metadata that becomes part of the tool's schema, ensuring AI models understand the expected input format.
Limit, int equals field. 10, description equals maximum number of results. G equals 1, la equals 100.
This defines a validated parameter with default value 10 using FastMCP's field class. The G equals 1 and la equals 100 constraints enforce a minimum of 1 and maximum of 100 results, preventing invalid input while maintaining flexibility. This pattern ensures type safety and self-documenting parameters in AI-callable tools.
A list.
This return type annotation declares the function returns a list. It enforces type safety by making the expected output explicit, enabling static type checkers to catch mismatches early.
Search the database with the provided query.
This docstring defines the tool's purpose for AI models and human developers. It becomes part of the tool's schema in FastMCP, ensuring proper documentation and discoverability in the tool registry.
Hash implementation.
This placeholder marks where the actual database search implementation would go. The function signature already defines the contract, so this is where you'd implement the query logic, result filtering, and limit enforcement. FastMCP tool schema definition. The field class integrates Pydantic validation directly into tool parameters, enabling both runtime constraints and AI-friendly documentation through type annotations. Validation rules like G and L silently enforce boundaries while remaining invisible to the client schema. This approach merges implementation safety with interface clarity in a single declaration.
The schema that restricts everything describes nothing.